This is part 2 of chapter 2.2. We're going to continue and we're going to talk about even and odd functions. A function f is an even function if f of negative x is equal to f of x for all x in the domains of f. The right side of the equation of an even function does not change if x is replaced with negative x. The graph of an even function is symmetric with respect to the y-axis. So before, when we talked about symmetry about the y-axis, we stated that if you fold the graph along the y-axis, the graph will meet up. The function f is an odd function if f of negative x is equal to negative f of x for all x in the domain of f. Every term on the right side of the equation of an odd function changes its sign if x is replaced with negative x. The graph of an odd function is symmetric with respect to the origin. So once again, when we talked about symmetry about the origin, if you flip the graph upside down, it will look like the same graph right side up. Alright, so let's go ahead and look at some problems. In this first one, it says we're going to determine whether or not the function h of x equal to x to the fifth plus 1 is even, odd, or neither. So first, let's check to see whether or not this is an even function. Scroll down a little bit. So to do that, we're going to set x equal to negative x. So I'm going to calculate h of negative x. Whenever I see an x, I am going to plug in negative x. Negative x to the fifth is just negative x to the fifth. So in order for this to be an even function, h of negative x must be equal to h of x. So this is our h of negative x, and this is my h of x. As you can see, these are not the same. So that means it's not even. To check to see if it's an odd function, we're going to look at h of negative x and see if it's equal to negative h of x. Well, we already calculated h of negative x. We just did that in the problem above, and we said it's this. So now let's calculate negative h of x. So basically, we're going to put a negative sign in front of x to the fifth plus 1 and then change all the signs. So I get negative x to the fifth minus 1. As you can see, h of negative x, which is this, we have to see whether or not it's equal to negative h of x. As you can see, these two are not equal. So that means that this is not an odd function. If you look at the graph, if you fold this along the y-axis, the graph does not meet up. And if you flip it upside down, it's not the same graph as it would be right side up. In this next one, we have h of x is equal to 2x cubed minus 4x. We're going to see whether or not it's even, odd, or neither. If it's an even function, we're going to set x equal to negative x. So let's go ahead and calculate h of negative x. Whenever we see an x, we're going to replace it with a negative x. When we simplify this, we get negative 2x cubed plus 4x. In order for this to be an even function, h of negative x has to be equal to our original function of h of x. As you can see, this is not equal to this. So this is supposed to be an arrow, sorry. So this is not an even function. Now let's see whether or not it's an odd function. To calculate that, we're going to see whether or not h of negative x is equal to negative h of x. Well, we already stated that h of negative x is negative 2x cubed plus 4x. Now let's calculate negative h of x. We're going to put a negative sign in front of the original function and then change all the signs. We get negative 2x cubed plus 4x. So as you can see, if we take h of negative x, which is this right here, it should be equal to this in order for it to be an odd function. And as you can see, these two are equal. So this is an odd function. Recall that if it's an odd function, if you flip the graph upside down, you'll get the same graph right side up. So this is the graph, and if you flip it, you should get the same graph. In this next one, we have h of x is equal to 3x to the fourth minus x to the sixth. We're going to see whether or not this is an even function. We're going to set x equal to negative x. Whenever I see an x in the problem, I'm going to change it to negative x. Negative x to the fourth power is just a positive x to the fourth power. And negative x to the sixth power is going to be a positive x to the sixth power. Don't forget we got this minus sign in front, so it's minus x to the sixth. So if we take h to the negative x, we want to see whether or not it's equal to our original problem. So if we look at this and this, they are the same. So this is an even function. To check to see whether or not it's odd, we're going to check to see whether or not h of negative x is equal to negative h of x. We've already calculated h to the negative x above. Now let's check negative h of x. I'm going to put a negative sign in front of 3x to the fourth minus x to the sixth, and then I'm going to change all of the signs. When I change the signs, I get negative 3x to the fourth plus x to the sixth. I want to see whether or not this is equal to this. As you can see, they are not equal, so that means that this is not an odd function. Okay, so not odd. So if it's right now it's an even function, that means it's symmetric about the y-axis. So this is the graph. If I fold it along the y-axis, as you can see, the graph will meet up. Next, we're going to talk about piecewise functions. A function that is defined by two or more equations over a specified domain is called a piecewise function. So in this example, we have a telephone company offers the following plan. It's $20 per month, and that buys you 60 minutes. Additional time will cost you 40 cents per minute. So this is the function. As you can see, it's broken up into two equations. Between 0 minutes and 60 minutes inclusive, you pay $20. If you want more time, you're going to have to pay the $20 plus 40 cents per minute. And that's for anything over 60. So we're going to calculate C of 40 and C of 80. So C of 40 means that T is equal to 40. We got to figure out, based off our T, what equation do we use? So since 40 is in between 0 and 60, that means we only have to pay $20 because we're only using 40 minutes. We're not going over 60 minutes. So for 40 minutes of talk time, you pay $20. Next, we're going to calculate C of 80. 80 is greater than the 60 minutes, so that means we have to use this second equation here. So whenever we see a T, we're going to plug in 80. So we end up with 20 plus 0.4 times this 20 here. You end up with 20 plus 8, which is 28. So for 80 minutes of talk time, you're going to pay $28. Okay? So like I said, depending on the value of t will determine what equation you will use. So now let's talk about how to graph a piecewise function. So as you can see, we have two different equations. When you graph them, you're going to graph it in pieces. So that's why they call it a piecewise function. So for the first one, we have f of x is equal to 3 when x is less than or equal to -1, and f of x is equal to x minus 2 when x is greater than -1. So let's go ahead and graph f of x equal to 3. Remember, f of x is the same as y. So when you can do a table of values if it's easier for you, but you should know that y equal to a number is going to be a horizontal line. So no matter what value you put in for x, your f of x is going to be 3. But make note that in this case, x has to be less than or equal to -1. So you can plug in -1, -2, -3, -4, as long as the values are less than -1. Your f of x will always be 3. When we plot this point here, I'm going to put a closed circle, and you'll see why in a minute. And the reason, well, I'll tell you right now, the reason why I'm going to put a closed circle is because -1 is included, because it's less than or equal to -1. So I'm going to put a closed circle. I'll show you a reason why we have to use an open circle in the next one. So I'm going to go ahead and plot these points, and it's just going to go straight across to the left. So this is your graph. As you can see, it's a horizontal line. I'm not very good at drawing on here, but it's a horizontal line. But now let's go ahead and do f of x equal to x minus 2. We can only do this for values of x greater than -1. Greater than -1. So I'm going to put in -1 in here, even though it's not included in the domain. The problem states x has to be greater than -1. But I'm going to put -1 on here, and I'm going to put an open circle at that point. So when I plug -1 back into this function, I get -1 minus 2, which is -3. I want everything greater than -1, so I'm going to put in 0. I can put in 1. I can put 2. And I can keep going, but I'm just going to do those three numbers. When I plug 0 in, I get 0 minus 2, which is -2. When I put 1 in, I get 1 minus 2, which is -1. And then when I do 2, 2 minus 2 is 0. So I'm going to plot these 4 points. When I do -1, -3, which is here, I'm going to put an open circle. This open circle lets me know that this point is not included in the graph. Okay, this point is not included in the graph, but I'm still going to draw it and put in an open circle. Then I'm going to plot 0, -2, 1. The next one is 1, -1, and then 2, 0. So this is my graph here. So like I said, the reason why they call it a piecewise function is because you have to do it in pieces. The next one we have f of x is equal to -2x minus 1 is when x is less than 2. And we have f of x is equal to x plus 4 when x is greater than or equal to 2. So let's go ahead and calculate f of x equal to negative 2x minus 1. Once again, we have to do this for values that are less than 2. So I'm going to include 2 in my calculations, but I am going to do an open circle. So when I plug 2 back into this function, I get negative 5. 2 times negative 2 is negative 4. Negative 4 minus 1 is negative 5. And then I'm going to put in some more values. Remember, they have to be less than um, they have to be less than 2. Okay, so if I plug 1 back in, I get negative 3. When I plug 0 in, I get negative 1. And when I plug negative 1 back in, I get 1. So let's go ahead and graph these points. I get 2, negative 5. I'm going to draw an open circle here. Then I have 1, negative 3, 0, negative 1, and then negative 1, 1. This is my graph. Next, I'm going to do f of x is equal to x plus 4. That's going to be values of x that are greater than or equal to 2. Okay, so I'm going to draw my table. But once again, I need to pick values of x that are greater than or equal to 2. So I'm going to put in 2, I'll put in 3, and I'll put in 4. So when I plug 2 back in, 2 plus 4 is 6. When I plug 3 back in, 3 plus 4 is 7. When I plug 4 back in, 4 plus 4 is 8. So when this 2 here, since it's included, I'm going to put a closed circle. So I'm going to plot 2, 6, which would be here. And then I got 3, 7, which would be here. And I got 4, 8, which would be a little bit off the graph, so right here. And I'll go ahead and graph my line. Oh, that's really crooked. This should be a straight line, sorry. So that's my graph. The points line up to a straight line, but I just can't draw a straight line. All right. Some piecewise functions are called step functions because their graph form discontinuous steps. And this figure shows the cost of mailing a first-class letter, f of x, in a country as a function of its weight, x, in ounces. What is the cost of mailing a letter that weighs 2.8 ounces? So if you look at this, you have these open circles and your closed circles. So you have the weight along the x-axis. So if you look at the cost of mailing a letter that weighs 2.8, we got the cost on the y. So 2.8 is going to be close to 3. And when you go up to the graph, as you can see, it's going to fall in this interval here. It's not going to include the weight of 2, but 2.8 will be included. It's closer to 3. So it's going to cost 63 cents. Or you can write it as with a dollar sign. Next, we're going to talk about how to find and simplify a function's difference quotient. And these can be kind of long, so I'm going to go through it step by step so you can see how it works. But you got to be careful in your calculations. The expression f of x plus h minus f of x all divided by h, where h is not equal to 0, is called a different quotient of a function f. So we have f of x is equal to negative 2x squared plus x plus 5. We want to find and simplify the difference quotient. So I'm going to do this in pieces. The first thing I'm going to calculate is f of x plus h. Whenever I see an x, I am going to plug in x plus h. So this will be negative 2x plus h squared plus x plus h plus 5. So you got to be careful when you multiply this out. We're going to take x plus h squared. We're going to FOIL this. Okay, so we're going to FOIL this out. We get x squared plus x times h plus x times h plus h squared. We're going to combine like terms. It's like terms here. So xh plus xh is 2xh. And now I'm going to multiply everything in parentheses by this negative 2. So I get negative 2x squared minus 4xh minus 2h squared plus x plus h plus 5. There are no other like terms that we can combine. So this part here is our f of x plus h. The next step is to take f of x plus h and subtract off our original function. So I'm going to take this long answer that we just got. I'm going to subtract off our original function. So I'm going to put minus a negative 2x squared plus x plus 5. So what happens is we just have to change all of the signs in the second expression. So I'm just going to bring this down and I'm going to change all the signs here. So I get plus 2x squared minus x minus 5. Now from here we can go ahead and see if we have any like terms that we can combine. Negative 2x squared plus 2x squared is 0. 5 minus 5 is 0. X minus x is 0. So once I've combined all my like terms, I'm left with negative 4xh minus 2h squared plus h. The next step is to now, we've calculated all of this, now we have to divide by h. Okay, we're going to divide by h. And as you can see in the numerator, we have an h in each term. I can go ahead and factor that out. When I factor out an h for the first term, I'm left with negative 4x. When I take out an h from the second term, I'm left with 2h. And when I factor out an h from this last term, which is the h, I'm left with 1. So now these h's that cancel out. And I have arrived at my final answer. So the final answer would be negative 4x plus 2h plus 1. So it's a lot of steps. And let me double check something. I think I made a, hold on. I think I changed my sign here. Okay, I made a mistake there. This should be minus. I forgot to bring it down. This should be minus 2h, minus 2h, minus 2h. There we go. I changed it to a plus sign accidentally. So this is the final answer. All right. So the last problem, we're going to do the same thing. We have f of x is equal to x squared plus 3. We're going to find the difference quotient. The first thing I'm going to do is calculate f of x plus h. Whenever I see an x, I'm going to plug x plus h in. And then I'm going to go ahead and FOIL this out. I get x squared plus xh plus xh plus h squared plus 3. This gives me x squared plus 2xh plus h squared plus 3. I combine these like terms. So this is my f of x plus h. Now we're going to take f of x plus h and we're going to subtract off our original function. Get x squared plus 2xh plus h squared plus 3 minus x squared plus 3. It's be minus x squared minus 3. So now we can go ahead and combine like terms. X squared minus x squared is 0. 3 minus 3 is 0. So we get 2xh plus h squared. So this is my f of x plus h minus f of x. The last step will be to divide this function by h. As you can see, an h is common in each one of the terms in the numerator. I can factor that out. And when I factor it out, I'm left with 2x plus h. Don't forget to divide by h. Here, these h's that cancel out. So my final answer will be f of x plus h minus f of x all over h is equal to 2x plus h.